All right, so last time we were naming ionic compounds. Now here's a little quiz for you. Why do we call them ionic compounds?
Because it's a metal mixed with a non-metal.
All right. I told you early on that when you see that a compound has a metal and a non-metal, that means that it's an ionic compound. However, we introduced a new definition for an ionic compound, which is kind of a lame definition because it's like it just says what the name is. But we called an ionic compound something that has a metal and a non-metal early on because we didn't know the term ion. We didn't know what an ion was. Do you know what an ion is now? What's an ion?
Iron?
Ion, not an iron, but an ion.
I don't know.
An ion is an atom, like an atom of sodium, for example. That's an atom. But when the atom has a different number of electrons than it has protons, it gets a charge. And then it becomes an ion. All right? So an ion is an atom that has a charge. And it has a charge because it has a different number of electrons and protons. Now here's another little quiz. Why does this sodium ion have a positive charge? How did it get a positive charge?
It has less electrons.
That's right. That's right. It lost an electron, has less electrons. Very good. And we can look at the periodic table and identify exactly how many protons and how many electrons this sodium ion has. Can you tell me? For the
11 protons, 10 electrons.
Very good. 11 protons, 10 electrons. Atoms don't gain and lose protons to become ions. They gain and lose electrons. Very good. So now we know what an ion is, and now we have a definition for an ionic compound. Ion and ionic come from the same place, right? It means that an ionic compound is a compound made of ions. All right? Very good. So the definition that I gave you previously about a metal and a non-metal, still, that's an easy way to identify ionic compounds. However, we've also begun to talk about polyatomic ions. Polyatomic ions. Do you have your list of polyatomic ions there?
Uh-huh.
All right, so here's that list of polyatomic ions. Notice that one of these polyatomic ions has a positive charge. Actually, two of them do, but only one of them forms compounds. So the first one, the ammonium ion, is a positively charged ion. So if I make a compound that contains ammonium in it, so for example, this compound, NH4Cl. This is ammonium chloride. Are there any metals in that compound? Let's look at the periodic table, see if we can see any metals.
No metals.
No metals. But even though there's no metals, it is still an ionic compound because it's made of ions. All right? So what I told you about an ionic compound, I mean, if it contains a metal, it's an ionic compound. That's true. But there are also some ionic compounds, the ones that contain the ammonium ion, that are still ionic compounds. Because the true definition of ionic compounds is a compound that's made of ions. Okay, is that all right?
Uh-huh.
All right. So I'm going to write down the name of a compound, and let's see if you can tell me what its name is. What is the name of that compound? Got to use our periodic table, right? Br is number 35.
Sodium bromine.
All right. But we don't say bromine, we say brom what? Bromide. Bromide. Right? And we follow the pattern of our favorite compound, NaCl. What is the chemical, what's the name for NaCl?
Salt.
No, it's sodium chloride. Sodium chloride.
Chloride.
Remember, we changed our definition for a salt. A salt is a compound that is an ionic compound. So all three of these are salts. All three of these are salts. And sodium chloride is that one's name. Sodium bromide is that one's name. How about this one? What's the name of this salt? This ionic compound.
Sodium fluoride.
How should it end? This is
Fluorine.
sodium. This is sodium chloride. This is sodium bromide. This should be sodium
Fluoride.
Very good. Fluoride. Have you ever heard of fluoride? You need to have
No.
fluoride in your toothpaste, and sometimes they have a fluoride rinse that the dentist gives you. Fluoride is an ionic compound with fluorine in it, sodium fluoride, because fluoride ions can help reinforce your teeth and make them strong. Okay, very good. Here's another compound, Na2O. Can you tell me the name of that compound?
Sodium oxide.
Very good. The oxygen turns to oxide. Sodium oxide. Excellent. Now let's get into our polyatomic ions. Let's see if you can figure out the name of this compound. Na2SO4.
Sodium. SO. Oh wait, SOs are two different things. Sodium sulfur oxide.
See down SO4? It's called the sulfate ion. You see that?
Oh, yeah.
All right.
Sodium sulfate.
Very good. Sodium sulfate. When we have compounds that contain the polyatomic ions, we don't change that to "ide." We just say the name of that polyatomic ion. So this is sodium sulfate. Sodium sulfate. Now, what are the ions that sodium sulfate is made of? What are the two different ions?
Metal.
The sodium ion. Very good. The sodium ion. And what's the other ion? It's the polyatomic one.
It's non-metal.
Well, yes, but this is the ion, that ion, and it's called the sulfate ion. It's the SO4 2- ion. So we have the sodium ion and the sulfate ion. And you see here, we needed 2 sodium ions. Why did we need 2 sodium ions for every 1 sulfate ion?
The sulfate lost 2 to become a noble thing.
Okay. Sulfate
Element.
didn't lose 2, but it has 2 extra electrons, right? That's why it's a -2 charge.
The extra and a sodium
Yep.
had to lose 2 to give it to.
That's right. We need 2 different sodiums to lose 2. Why doesn't sodium just lose 2 and form a 2+ ion? Why doesn't that happen?
Because then it has to lose 1 later if it wants to be a neon.
Yeah, if it loses 1, if it loses 2, so sodium has 11. If it loses 2, it's only going to have 9, and then it's going to be like fluorine. It's not going to be like a noble gas. So that's why sodium never loses 2 electrons. Okay, very good. Here's another one. Can you tell me the chemical formula of, the name of this compound? The name of this compound?
Potassium. phosphate ion.
Say that again.
Potassium phosphate ion.
All right, you don't have to say phosphate ion, you just say phosphate to name the compound. Very good. So this is potassium phosphate. And what ions is the compound potassium phosphate made of?
Phosphate.
It has the phosphate ion in it, PO4 3 minus. What's the other ion?
Oxygen.
No, it's the potassium ion. The potassium ion. What's the charge on a potassium ion?
11.
Well,
Oh, no, 19.
that's not the charge, that's the number of protons. But if it has a charge, potassium, what kind of a charge is it going to have?
Plus.
Positive 1. Positive 1. And we need 3 of them, 3 potassiums, because we needed 3 electrons to go to the phosphate. Okay, very good. Now, I'm going to do something different. I'm going to tell you the name of the compound, and you're going to tell me the chemical formula. All right? Ready? Magnesium sulfate. Magnesium sulfate. Can you tell me the chemical formula for magnesium sulfate?
Mn.
Mn? Is that 25? Huh?
Mn25.
Is Mn magnesium or is 12 magnesium, Mg?
Oh, 12 magnesium.
Yeah. What is Mn? Can you say that word? That's a hard one.
Manganese.
It's manganese. Manganese.
Manganese.
Okay, very good. So Mg, and then what's the sulfate?
Oh, it's on that page. Oh, SO3 negative charge. Negative
SO3, isn't that sulfite?
sulfate.
Is it 2 down from sulfite?
No, yeah, I said sulfate.
Oh, what is it? What's the chemical formula? Or what's SO what?
SO4 negative 2 charge.
Oh, very good. SO4. Very good. So the 2 ions, that's magnesium sulfate. Magnesium sulfate. Now, are there more than 1 magnesium per sulfate, or is it just a 1-to-1 ratio?
Needs 1. That's it.
That's right. How did you know that?
Because magnesium wants to lose 2, so it gives up 2 to the sulfate, and sulfate needs 2.
Very good. So it's a magnesium with a 2 plus and sulfate with a 2 minus. Excellent. Okay, another one just like that, all right? Here's the next compound. Lithium. Lithium chromate. Lithium chromate. What's the chemical formula of lithium chromate?
Lithium. Oh, lithium's Li.
Li. And here's a hint. Chromate is a polyatomic ion.
Yeah, I'm looking.
Did you say it? I couldn't hear you.
No. Oh. It's. Is that right? No. CrO4.
CrO4. Very good. So, lithium and chromate are here. Now, are there more than one chromate per lithium or more than one lithium per chromate?
1 second, I lost chromate. I have to find it again. Oh, found it. Wants a -2 charge.
Okay. What about lithium? What does it want?
+1. So you need 2 lithium for each chromate.
All right. Very good. That's the chemical formula for lithium chromate. Fabulous. Here we go again. Ready for another one?
Yeah.
Here it is. Calcium nitrate. Calcium nitrate. What's the chemical formula for calcium nitrate?
Ca is calcium.
Calcium is Ca. Good.
And nitrate is NO3 negative charge.
Okay, NO3. So, do we need more than one calcium or more than one nitrate?
Calcium. We need 2 nitrate for each calcium.
All right, so do I put a 2 like that? Is that right?
Yes.
Okay, does it look kind of weird?
Yeah.
What am I missing?
Oh, the negative sign at the top.
No, I'm missing the parentheses. Remember, I put the parentheses on there to show that that 2 goes with that. Okay, very, very good. Last one, all right? Ready for this one?
Okay. Yeah.
All right, here we go. Ready? Strontium phosphate. Strontium phosphate. What's the chemical formula for strontium phosphate?
For phosphate, it's PO4.
Good. Here's a hint. Strontium is underneath calcium.
Found it.
Good.
SR.
SR. Very good. Strontium phosphate. Now, do I need more than one strontium or more than one phosphate?
You need 3 strontium and 2 phosphate.
Okay, very good. Like that?
No, you need the
Parentheses?
parentheses.
Very, very good. Strontium phosphate. Excellent job. That was fabulous. So, I'm going to give you one, and you're going to write down the chemical formula for me, okay? So, I'm going to, why don't you write down on your paper? Well, no, you don't have to write this on your paper. I'll just have it up here, and we'll look at yours, okay? So, we're going to look at your sheet there. There we go. And I'm going to give you a compound. And I'm going to give you magnesium phosphate. Magnesium phosphate.
Mg.
Good.
And then phosphate?
Yeah, magnesium phosphate.
Oh, yeah, phosphate.
Good. Those are the ions, magnesium phosphate. Now, how do they come together? Just draw how they come together below.
Here?
Or over to the side, yeah.
M. So, these. So, 4. These. 2.
Okay, very good. Now, there's only one thing that we have to look at there. When you write an ionic compound, you don't include the charges on the individual ions, right? Very good. That's it. Excellent job. 3 magnesiums for every 2 phosphates. You can write those there. That's all right, because those ions are the ions that the magnesium phosphate are made from, and that's important to recognize. Very good. So it's okay to write the ions like that, and then writing the compound all together, you don't include those charges. Okay, very good. Excellent. Now here's another question, another tricky question. How many ions are in 1 unit of sodium sulfate? Sodium sulfate. Okay? Sodium sulfate, and after we write sodium sulfate, we want to know how many ions are in a unit of sodium sulfate. So why don't we first write what sodium sulfate looks like?
Sodium sulfate.
Sodium sulfate.
Where at?
Write it on your paper there, sodium sulfate.
The words?
Or no, just write down the chemical formula if you know it.
Yeah, but I can't find sodium sulfate.
Sodium? Sodium is Na, it's number 11.
Oh, sodium sulfate. Where's sulfate? N.
Very good, sodium.
Now sulfate.
Now sulfate.
Okay. SO42.
Yeah, SO4 with a 2- charge. Very good. Positive charge. Very good. Now, how do they come together?
Does it matter which order you put it in? Like Na has to be first?
Yeah, the sodium does come first. The metal comes first. Or the positively charged ion, the cation, comes first.
N A
Nope, that's it. Very good. Nothing else, right? Yeah, just one. But you don't need to put the brackets on there when there's just one. Okay, very good. And you don't have to put the 1 down there either, right? Very good. Excellent. Sodium sulfate. Na2SO4. Now the question was, how many ions are in 1 unit of sodium sulfate? So you have 1 unit of sodium sulfate there. Now we want to see if we can count up the ions. How many sodium ions are there?
2.
2.
Wait, no.
That's right. There's 2 sodium ions. Right? That's what that 2 means. How about sulfate ions? How many sulfate ions?
1.
1. So that's a total of how many ions?
2.
3. 2 sodiums
3.
and 1 sulfate. How many different kinds of ions?
2.
2. 2 different kinds. There's sodium kind and there's sulfate kind. But there's 3 ions per unit of sodium sulfate altogether. Very good. Okay, now here's a hard one. You ready for a hard one?
Yeah.
Here it is. Iron nitrate. Iron nitrate. What's the chemical formula for iron nitrate?
Iron nitrate?
Yeah, iron nitrate. Iron is element number 26.
Nitrate.
And nitrate is a polyatomic ion.
Wait, so you want me to write it in the chemical form?
That's right. Write the chemical formula for iron nitrate. Good. That's iron. All right. Now, that's the tricky part, right? What did we say about atoms, metals, that are in the transition metal zone? Do you remember?
They always want to gain?
No. In the blue zone, the transition metal zone, and also this post-transition metal zone, or at least some of the post-transition metals, they have multiple charge states. They have multiple charge states. And the charges that they gain don't give them the same number of electrons as the noble gas, the noble gases. So iron, for example, will either form a +2 or a +3. A +2 or a +3. And so when I say, what's the chemical formula for iron nitrate? All you can say is, I don't know. I don't know, because I don't know what the charge is on the iron in iron nitrate. So go ahead and write down the nitrate. That's good. NO3. And it has a -1 charge. Okay? But iron doesn't have, we don't know what the charge is. Because when somebody says a name of an ionic compound that contains a transition metal, we don't know what the charge is because it's not a representative element. It doesn't follow the same rules as the first 2 columns do. And so we need a better way to name the compounds that contain transition metals. And this is the way. The name of iron nitrate has to either be iron 2 nitrate or iron 3 nitrate. Iron 2 or iron 3. And if it's iron 2 nitrate, that means the iron has a +2 charge. If it's iron 3 nitrate, that means the iron has a +3 charge. All right? So can you then write the chemical formula for iron 2 nitrate?
And, oh,
All right, now what did the 2 mean when I said iron 2 nitrate? Did it mean there was 2 irons? Or did it mean the iron had a +2 charge?
+2 charge.
Yeah, it has a +2 charge. So what does that mean? If it has a +2, then that means that how many nitrates are we going to need?
3.
3 or 2?
2.
2. That's right. Because each one is a -1. Very good. And then we don't need that +2 sign up there for the iron, do we? Very good. So the chemical formula for iron 2 nitrate is Fe and then 2 of the NO3s. All right, why don't you draw a line underneath all of that, and then underneath that line, write the chemical formula for iron 3 nitrate. Iron 3 nitrate. Remember what that 3 means. It means that the iron has the +3 charge. Very good. That is iron 3 nitrate. Excellent. Now, can you explain to me why we had to call it iron 2 or iron 3 nitrate? How did we know that we'd have to call it that?
Because iron, it has different states of metals.
Charge states.
Charge states, so it could be 3 or 2 away from.
That's right. That's right.
Probable.
It can either find stability by forming a +2 charge or by forming a +3 charge. Very good. Now, how can we recognize that? If I have a compound and I don't know if it's supposed to be named with a number with it, how are we going to know? What kind of metals need a number when we're naming them?
We don't.
Well, we do actually. It's the transition metals, the blue zone. So why don't you go back to the screen now? Okay. So the transition metals, the blue ones are the ones that help us know that we need to use a number to name them. And this is how you name, this is where you put the number. You use a Roman numeral number. So you say iron 2 with the Roman numeral 2, and then you say nitrate, or iron 3 nitrate. And the chemical formula for iron 3 nitrate, like you showed us, is FeNO3 with 3 compound, with the 3 nitrates. Okay? So, what is the chemical, or what is the name? No, so let's just do this first. What is the chemical formula for chromium 3 chloride? What's the chemical formula for chromium 3 chloride? Tell me what to write down. Cr. Speak into the microphone.
Is chloride a ion?
Chloride is this one right here. It's just number 17, right? It's an ion, but it's not a polyatomic ion.
Cl.
Uh-huh.
And so you write there. Oh, 1. No, 2.
A 2 for the chloride or a 2 for the chromium?
3.
A 3 for
A
what?
3 for the
3 for the chloride. Very good. Because the chromium is a Cr plus 3 ion, and the chloride is a Cl minus ion. So we need 3 of the Cl minuses for every one of the Cr plus 3 ions. How did we know this was a chromium plus 3?
Because of those 3 between chromium.
That's right. Very good. All right. Here's another one. Why don't you tell me the name of this compound? All right. What's the name of this compound?
Nickel. Nickel sulfate.
Nickel what?
Sulfate.
Nickel sulfate? Oops.
Yeah.
Just like that, or do I need something else?
You need to put nickel is put a 3 between nickel and sulfate.
What's the charge on the sulfate?
Sulfate charge is -2.
-2.
Oh, so put a 2 between nickel and sulfate.
Very good. And the name of this compound then is nickel 2 sulfate. Nickel 2 sulfate. Excellent job. One more and then we'll be done, okay?
Okay.
One more. Here we go. What is the name of this compound? Fe3PO4 2.
Oh. Iron phosphate.
Very good. Now, do we have to write a number in between the iron and the phosphate?
Yes. 3.
3? And why do we write the 3 there?
Because phosphate has a -3 charge.
Phosphate has a -3 charge? I thought this was to tell us what the charge was on the iron.
Yeah, but if the iron had 3, since the iron has 3, you want to put a 3. It's so the phosphate only needs 1 and the iron only needs 1.
But see how the iron, how many phosphate ions did I need?
2.
2. So it was PO4, 3 minus, and then another PO4, 3 minus.
Iron 2.
That's right. Very good. Iron 2 phosphate, because there's 3 of these irons, and so it must have been a +2 charge. Very good. Iron 2 phosphate. Wow, what a good job. You did a fabulous job today. You're learning how to name ionic compounds. Okay, see you later.